So today we're working on lesson 1.3, which is on the topic of fractions. And a fraction is going to be built out of what we just studied, which is the division of two integers. Which means fractions could have positive numbers, negative numbers, both are fair game with any of the operations. Now we call the top number of a fraction, we call this the numerator. And a lot of us, I'm sure, already know this, and we call that bottom number the denominator. So we have a couple examples here. 4 over 7 as a fraction. We could have the negative up top, so negative 9/14. That's how we'd say this as a fraction, or 5 over 12 over here. With the 4, negative 9, and the 5 is our numerator for each of these, and the 7, 14, and 2 are the denominators. Now, when we're working with fractions, sometimes we might already have an integer that's not a fraction, but we need it to be a fraction in order to either add or multiply, whatever it might be. So a nice thing about taking integers is we can make them a fraction super easy by including the number 1. So if we rewrite 4 as 4 over 1, 4 over 1 is just 4, right? Because 4 divided by 1 is 4. But now we have it as a fraction, so it's in the form that we can use. So we can do something similar over here with that negative 19. We could put the negative 19 up top and just a 1 down below. When we divide that, we get back to where we started, but now it's in a form that we can use for fractions. But when we deal with fractions, we can have issues when it comes to 0. So we have two cases, 0 divided by 1, or really any number, and then any number, for this example, 1 divided by 0. So let's start with the first one. The numerator, a lot of the times, we can kind of view as how much we have of the possibilities in the denominator. So if we have 0 of the 1 possible, well, then we just have 0. And this would be true no matter what the denominator was. If we had 0 pieces out of, say, 20 available, we'd still have 0. So if 0 is up top, we get 0. But if we're looking over here where we're dividing by 0, how can we have 1 available of the 0 that exists in the first place? So this creates an issue for us. When we end up with this, we call this undefined. It's undefined because we can't divide by 0. So 0 in the numerator, we're good to go, totally fine. 0 in the denominator, already can't deal with it, that's undefined. Now, where we will be doing a bunch of our different operations, we can even do PEMDAS and order of operations with fractions. No matter what operation we're doing, it's always going to end up being a problem of simplifying our final answer. And we do this by looking for a common factor that both the numerator and the denominator share. And then with this common factor, we can cancel it out, as we're about to see. So for the first, we got 4 over 12. Do 4 and 12 have anything in common? Some of us might go, oh, they're both even. They have 2, which is true. But there's something even bigger than that, right? We could leave 4 to just be 4. But 12 we can write as 4 times 3. So I just rewrote it so we can see what they have in common. Now we see there's a 4 up top and a 4 down below. Well, what's 4 divided by 4? Well, that's just 1. So we can call this canceling when we have that same number divided by itself because it gives us just 1. However, one note to make is that a 1 is left over when we cancel. So we need to remember, when we cancel that top, we need to make sure to put a 1 in its place. It's not going to have nothing up there. And for that 1 down below, we don't need and typically put this 1, because ultimately we have whatever's left over times 1 is just what's left. So for us, that's the 3. So now we have something like 4 over 12, which simplifies down to 1/3. And 4 is a third of 12, so that works out. Now, try to do the same idea over here where we found what common factors these guys had to cancel with this 25 over 15. So give that a pause and see how far you can get doing that same idea of simplifying. All right, hopefully you gave it a shot. So I'm going to look at 25, and 25 is 5 times 5 and 25 times 1, but 25 times 1 doesn't really get us anywhere. So I'm going to write that as 5 times 5. And then 15, it also has a factor of 5, right? 15 is 5 times 3. Now, just like with this first one, if we have things in common, we can cancel them, but it's only for each pair that we get to cancel. So we can cancel 1 5 up top, 1 down below, but we got to keep this extra 1 up here because unless there's another 5 in the denominator, we don't get to cancel that out. Now, with those canceled, whatever we have left, this 5 over 3 is our simplified fraction. However, this one's a little different than what we've seen so far, and that's due to the fact that that 5, that numerator, is a little bigger than the denominator down below. So we're going to turn the page and see what that means. As we move on to the second page, what we see up top are fractions that look like what we saw at the bottom of that first page. And the key thing here is that the numerator is always larger than the denominator for all of these cases. So anytime we have a fraction that looks like this, we call these improper fractions. Now, you've probably guessed it. If it's the other way around, where the numerator is smaller, something like 1/2, we call those proper fractions. Now, improper fractions can be rewritten if we write it with an integer along with a proper fraction, as we'll see in a second, such as what we have here, right? So we have these integers, the 2, and then the fraction tagged on with it. We call these mixed numbers. And they're mixed because it's the mix of the integer along with that fraction. Now, sometimes we might be given a problem as a mixed number, and it might be easier to work as something improper, or vice versa. So we want to make sure we can go back and forth between these two forms. So we got 2 examples here. One where we want to write this as a mixed number, and then one where we want to write this mixed number as an improper fraction. So if we start with an improper fraction, step 1 for making it into a mixed number is we need to do a little bit of division. We need to divide 13 by 3, or another way to think of it is how many times does 3 go into 13 nicely without anything being remaining? Well, if you're thinking about it a little bit, 3 times 3 is 9, so that's close. But we can go a little bit more. We can get one more 3 in there. 3 times 4 is 12. So we know 13 over 3 is going to give us 4 whole pieces. And then what we're looking at is the remainder over 3. Well, 3 times 4 is 12, and it's 1 more to get to that 13. So we can write this as 4 1/3. Now, a key thing for doing this is that every single time we do it, that this fraction we make right here is always going to be a proper fraction after the fact. So say we saw, oh, maybe we'll just try the 3. Well, we'd say 3 goes in here 3 times. So you might say 3, but the remainder would have been 4/3, which is still improper. So every time we change it into a mixed number, you just have to make sure that that fraction we get out of that is going to be a proper fraction. Now, if we're given that mixed number, a little bit easier. So over here, it's kind of a little bit of guess and check. But if we start with that mixed number, our first step right here is to multiply the denominator times that whole number, that integer. So for us, that's 2 times 7, which is 14. And then from there, you add the numerator. So you kind of go in a nice little circle. You multiply the denominator by the whole number, and then you add the numerator. So 14 plus another 3, that gives us 17. And then this is staying over the original denominator. Now you'll notice that for both writing it from improper to mixed or vice versa, the denominators are never changing. So over here, we still have to have it over 3, and over here, we're going to keep it over 7. It's just the numerators that change for us. So again, when we get into operations, we might be seeing something that's a mixed number, might be easier to make improper, or vice versa. Might also help with simplifying. So being able to switch back and forth is a very useful tool. And that brings us down to the very first tool we need in order to do the basic of addition and subtraction, which kind of gives away our first little blanks right here. In order to add or subtract any fractions, we need to find what's called a common denominator between the two fractions. So this is a number that both denominators go into. So we'll see what that means in a second. The easiest way to do this is to just multiply our two denominators. Because then just by definition, say we had 2 and 6, you multiply that, you get 12. Well, 2 has to go into 12, and so does 6, because they're the numbers that made it. So the easiest way to do this, a little star on that, is just to multiply each denominator by each other. Now, we have a special one of these that when you've worked with fractions before is probably the one you always try to aim for. And this is the smallest such number that both denominators go into, and this is called the least common denominator. Do a little abbreviation there for you. Or, written out abbreviated, that's our LCD. And if we can find this before we do our operations, it's really nice because it saves us from having to simplify after the fact. Now, if we just find any common denominator and then add or subtract, as we'll see on the next page, we'll have to finish it off with a little bit of simplifying at the end. And both results will get you to that same final product, but if we can get to that LCD first, it means that it saves us a little bit of time. But first, let's practice finding common denominators in general. So if we have two fractions, we want to get them ready to either add or subtract, we want to make sure they're both over the same denominator. So without them being over the same denominator, there's no real basis to kind of connect the two, so that's why we need to do it. Now, again, what is the easiest method, instead of just guessing and checking, is to just take the both of the two denominators and multiply them by one another. If I just multiply these together, 3 times 5, I get 15. Now, we need to double check. This is a number that both denominators have to go into. Well, let's see. 3 goes into 15, right? It goes in 5 times. And 5 goes into 15, it goes in 3 times. Now, conveniently for this one, this is also the LCD. And I think we're just actually a little bit lucky that that's the case, because we'll see when that doesn't happen necessarily. Now, if we were to use this common denominator to add these fractions, it means that because we have the LCD one more time, we don't have to simplify at the end. It's already done for us. Now, let's move on here to the second example. Again, the most common method is just to multiply the two numbers together. So 2 times 14, and that gives us 28. Now, again, just by construction, 28 is something they both go into. 2 goes into 28 14 times. 14 goes into 28 2 times. But is this the LCD? So this kind of poses a question when we're finding these common denominators. Sometimes the common denominator is already there for us. And if we don't see it yet, it's sitting right there in plain sight. The common denominator here that is the least common is 14 itself. So any number goes into itself one time, so that's good to go. And 2 actually goes into 14 7 times. So the LCD is actually 14. So if we see the bigger of the two denominators, when we're doing common denominators, that both values go into it, that already becomes our lowest common denominator. Now, let's see, why do we even need this in the first place, and check out how we do each of our 4 operations when it comes. So as we get onto this third page, just like we had to have certain rules when we had integers with adding, subtracting, multiplying, and dividing. Same thing happens with fractions. Now, first we're going to approach adding and subtracting. They're done the exact same way with fractions. In order to do this, as we saw on the page before, we need a common denominator. Denom for short. And again, ideally we'll get the least common denominator, which saves us from having to simplify, but common denominator overall works just fine. And then once we found a common denominator, we need to make sure we multiply the top and the bottom of each fraction by that value to find the common denominator. And we'll see what we mean by that in just a second. Once everything has that common denominator, you're only adding and subtracting across the top. So it's only the numerators at the end of the day that you end up adding or subtracting from one another. The denominator is just there to kind of relate the two fractions to one another. So let's look at an example. If we look at our first example, we have 1 over 3, 1/3. We want to add 2/5. Now we can only add them if they have the same denominator. As we just saw on that last page, not only is it a common denominator, but the least common denominator of 3 and 5 was 15. So we know what the denominator needs to be. So now we're going to approach each of these two fractions one at a time to change its denominator to be 15. Well, if the bottom one here is 3, how do you change 3 to a 5? You multiply, or sorry, 3 to a 15, you multiply it by 5. However, we just said we have to multiply not just the bottom, but also the top of that fraction. Now, we're going to do the same thing over here for the 2 over 5. If we want that 5 to be a 15, we need to multiply it by a 3. But if we multiply it by the bottom, we have to multiply it also by the top. So we're going to rewrite each of these two fractions over here to see what we get. Well, for both, the denominator is 15. We just created that. So both of these will be over 15. That's what we want to see. And for the first fraction, it's 5 times 1, which gives me 5. So now it's 5 over 15. And then for a second, it's 3 times 2, which is 6. So we get 6 over 15. So that's what we mean by once we know what value we need to multiply each denominator by to make it common, we got to make sure we also include the top of that multiplication. Well, now we're on to this last little step. Then we add across the top. So if we're only adding across the top, 5 plus 6 gives us 11. And we don't have to do any other changes to that denominator. Now, if we want to be extra sure, we could double check, do 11 and 15 have anything in common that we could cancel out? They don't. Only 11 and 1 go into 11. So that's our final answer for the first one. So use that same idea. That second example on our second page might come into play to help you out. On this second example right here, take a minute, pause the video, give this a shot, and remember, when we change the denominators, make sure you multiply the top and bottom. All right, hopefully you gave that one a shot. As we come back together, we'll work it out. So now we got two denominators we need to change, right? We need to be common. So on the last page, we said we should multiply them to one another. That gives us a common denominator. Well, we could do that. 4 times 8 is 32. And then we can multiply top bottom on the first by 8, top and bottom on the next one by 4. But there's something a little easier here for us. What do we know about 4 and 8? Well, 8 goes into 8, right? It has to go into itself. But how many times does 4 go into 8? Does it go in nicely? Yeah, right? It goes in 2 times. So we already have a common denominator, which means that that 8 was our LCD, or least common denominator. So here's a nice thing if we can spot that least common denominator already part of the problem. When we go to change our first fraction, how do we make this 4 into an 8? We multiply it by 2. But that means we got to do the top as well. Now what happens for the second one? That's the nice thing about it. It's already that 8 as the denominator, so we don't have to change a single thing. We only have to change now this first fraction. And we did that because we noticed that was our least common denominator. So change my first fraction. Again, both of these are over 8, but now this one has subtraction. Now in the first one, 2 times 3 gives me 6. And the other one, we didn't have to touch at all. It stayed just a 5. And now we're adding or subtracting across the top only. So I already know my final answer has to be over 8. We've got to keep the same new denominator. And then 6 minus 5 is 1. So big thing to remember when we add or subtract is we have to be finding that common denominator. Now, it doesn't have to be the least common denominator, but if we do, we save ourselves a ton of trouble from not having to change one of our fractions. Now we move on to multiplying. Multiplying with fractions gets a lot easier. And in fact, we're going to see a lot of the numbers will disappear for us on a lot of problems, which will be really helpful. So when it comes to multiplying fractions, you, believe it or not, you just multiply across the top and across the bottom. So you'll multiply across the top, separately multiply across the bottom, and whatever you get is a fraction you can simplify, and that's all it is. So let's look at this first example. We multiply across the top, so you get 2 times 3 up top. You multiply across the bottom, you get 3 times 4 on the bottom. Well, 2 times 3 is 6. And then right here we get 3 times 4 is 12. But we can simplify this guy. What goes into 6 that also goes into 12? Well, 6, right? So we know 6 goes into itself once and into 12 twice. So we could ultimately simplify that 6 over 12 into a nice simplified fraction of 1/2. Now, give this second example a shot. Give it a quick pause in a second and see if there's something you notice. Some of you might have already caught it. Something that we could have done at the beginning of these two problems that we're not going to cover till down below with division. But if you see the thing I'm talking about, let me know in the comments with your notes that you did early. Otherwise, we're going to be working on it down below. So again, give this guy a shot on your own. Alrighty, hopefully you pause it, give it a shot. Well, if we're just going to treat it like our other one over here, we multiply across the top. We get -2 times 5. Multiply across the bottom. We get 3 times 4. Now, -2 times 5 will keep it negative, so -10 over denominator of 12. Now, take a moment to think. Is this fully simplified? How can we tell? Well, a nice way to start is if we know our answers are even, we know they each have at least a 2 that they share that we can cancel out. Well, 2 goes into this 10, we just saw, not 5 times, but -5 times. Because if we just take the 2 out, it's got to stay negative. And 2 goes into 12 6 times. So if we can see that we can do this simplifying like this without rewriting the 10 as 2 times 5 and rewriting 12 as 6 times 2, by all means, go for it. But the main thing to remember when you multiply is you're multiplying across the top completely by themselves, and then it completely by themselves also on the bottom. Then you simplify. So that leads us now to our last operation we're going to do, which is division. And division is going to be a ton like when we did subtraction with integers. We're going to try to avoid it at all costs. And the nice thing about doing division with fractions is we're not going to use division at all. We're actually going to use the operation of multiplication. And we do this through a saying that I already know a bunch of you know. We kind of got it mixed up already with our integers section, right? In integers, we did keep, change, opposite. But with fractions and division, we have keep, change, and I can already hear some of you saying it, flip. So we get the keep, change, flip when it comes dividing fractions. Now, as this is prep for Algebra 1, I just want to make note, This flip we do, that we'll see in a second, is that we just take the top and we replace it with the bottom. So we take the numerator and denominator and switch their places. In Algebra 1 and beyond, we call that taking the reciprocal. So a little bit of new math terminology for us. That flip is also called the reciprocal. So we'll kind of see both of those used throughout this year. Now, we're going to do 2 of these like above. We're going to do 1 together. We're going to do 1 on our own, and that'll finish off our operations of fractions. So first things first, when we ever do division of fractions, always start with that keep, change, flip before anything else. So that tells us we keep the first fraction. So we keep that 2 over 3. We change the operation we're using. So instead of even dealing with division, I'm going to deal with multiplication. And then we flip or take the reciprocal of that last fraction. So instead of it being 4 over 9, we can write it as 9 over 4. Now here is something that some of us may be caught up above when it came to the multiplication that I'm going to make note of right now. You can cancel, or sometimes it's called cross-canceling, when you're multiplying fractions. And here's what we mean by that. This is a tool we can use that we don't have to use, but it can save us a ton of time if we see it. So let's say we don't see anything at all. The next step we would do is multiply like we did above. So we multiply across the top, multiply across the bottom. However, where we normally saw canceling happen just top and bottom, we can do this cross canceling when it comes to multiplication to anything that's diagonal from one another as well. So when we look at the 2 and the 4, do they have anything in common? Yeah, right, 2. 2 goes into itself 1 time, 2 goes into 4 2 times. So those got cross-canceled, just like if we had 2 over 4 vertically. And we actually have one more going on, right? We have that 3 and the 9. 3 goes into itself once, and 3 goes into 9 3 times. So I'm going to rewrite what our new fraction of multiplication becomes. We have 1 over 1 now times 3 over 2, which is a lot smaller numbers, which is nice to work with, instead of, say, 18 over 12 or bigger numbers and say the problem down below. So now that we did that cross-canceling, which again, you don't have to cross-cancel. You could have dealt with the bigger numbers, but this cross-canceling, when it comes to multiplication and division, this is the same as finding that least common denominator with addition subtraction, where it does a ton of that simplifying for us in the beginning. So if we do it, save us time when simplifying. Well, that last little bit of this problem, we need to multiply across the top. We get 3 times 1, which is 3. Multiply across the bottom, we get 1 times 2, which is 2. And for now, unless I say otherwise in the problem, it's totally fine to leave it as an improper fraction of 3 over 2, and we don't need to rewrite this as 1 1/2 or a mixed number. So lastly, as we come to this bottom problem, just like above, give this one a go, so give it a pause in a moment, and again, do the keep, change, flip, which is keep the first, change division to multiplication, and then flip that second fraction. And if you can see it, try to do some canceling or cross-canceling on this one and see if you can kind of catch that. So give it a pause, give it a try. All right, hope you get that one a shot. We're going to do this one again just like we did above. We keep that first fraction, but it has a negative with us. So I'm just going to put that in parentheses like you guys saw me do with order of operations, just so I can keep track of it. I'm going to change division to multiplication. And now I'm going to do that flip, or in more mathematical terms, that reciprocal. I'm going to take the reciprocal of the second fraction. So the denominator is now up top, and the numerator goes down below. Now, if the next thing you did from here was just multiply across and get negative 30, multiply across, get positive 10, and then hopefully see you could simplify that. Awesome. However, if you didn't see a little extra something, here's where it is right here. 1 over 5, the negative 1 over 5, no canceling here. We do have a little canceling over here though, right? So when we have the 30 and over 2, what do both of these share? Well, 30 and 2 share 2. 2 goes into 30 15 times. 2 goes into itself once. But if you see it a little more, we can do that one more time, right? It's not with the 1 down below, but it's that diagonal canceling, that cross canceling. We have the 5 now diagonal with a 15, but they both share a 5. Now 5 goes into itself once, and even though this is already canceled a little bit, that 30, we can keep going if it cancels with something else. That 15 is now going to turn into a 3. So if you saw that, awesome. If you didn't, no big. You're still going to get that same end result either way. So I'm going to rewrite this just so I can see what we have going on. We have -1 now over 1. And then we have now not 15, but we canceled it twice, right? From 30 to 15, then 15 to 3 with that 5. We have 3 over 1. Well, it's just multiplication. Ton of stuff already canceled out. So now we're just multiplying across the top and across the bottom. We have -1 times 3, which is a -3. And then we have 1 times 1, which is 1. Now, where this is a fraction, this is a really nice fraction because it's divided by 1, which we could just rewrite that as -3 divided by 1 or -3. Now, there's one little note I want to make about this guy right here. It's just kind of about form. We could write this as -3 divided by 1. So the negative's on the 3. This is the exact same as if we did 3 divided by -1 with that negative on the bottom. And this is the exact same as -3 over 1. So that negative could be out front. So if we go forward and you see a negative on the top, the bottom, or out front of the whole fraction, those 3 are the exact same, and you can change it in the form that you're most comfortable with. So one little note to make on that. Otherwise, that final note with division is that not only can we cross cancel to help us out, we can do it a repeated number of times that save us the trouble of simplifying at the very end. And that is all we have on our basics for fractions.